Today, I want to introduce you to the world of modeling trig. This is one of the most amazing things you will ever do in your life. So let's give it a try. Amazing. Okay, so yeah, amazing, but amazing in your life? Maybe, maybe not. Anyway, here we go. Let's just do it. So here I've got some data. The data is starting in January. Got a temperature of 28 degrees Celsius. It starts decreasing as we get to the colder months. This is down in the southern hemisphere, so winter is in the summer months for those of us from the northern hemisphere. It gets cold, then it starts warming up, and then of course it would make sense that we go back to January. It would go back to its hottest month and then start cooling off again. Alright, so we have an idea here that this is somewhat cyclical. Some type of cycle going on here. Now, we don't have all the points. You could graph this. You could draw kind of some type of scatter plot, and that might be helpful. I'm just going to go ahead and deal with what I have, right, and try to work with it from there. I don't want to have to graph everything every single time, so let's give it a try. So, in the last video I did, at the very end, I introduced you to this. Alright, now with this formula, really it's just the transformations that are occurring, but there are some significant pieces, right? This is the amplitude. This is the principal axis. Now this is the third time you're getting this, and so you should have figured this out by now. The B is not the period, but it is related to it. Period equals 2 pi over B. And then the C is just whatever we need to do to get that horizontal shift where it needs to be. Okay? So let's go ahead and look at the data. Amplitude, remember, if I have some type of graph and it goes amplitude I can get by taking the maximum value and the minimum value and finding the middle, right? Not the middle value, but the distance from there to the middle value. Okay, some people actually like to do the principal axis first because then they know what that middle value is and they can work from there. So we can go ahead and do that. We can do the principal axis first. The principal axis should be halfway between the maximum and the minimum. So just looking at my table, the maximum is 28 and the minimum equals 15. So in between those, that's 28 plus 15 divided by 2. So 28 plus 15 is 43, and then divide that by 2. So 43 divided by 2 should give me 21 and a half. Alright, so that means this center value is at 21.5. That's my D. Done. I've got the principal axis. Okay, now I should be able to get the amplitude really easily because the amplitude is just the distance from the maximum to there or from the minimum to there. And so 28 to 21.5, you could just subtract those, which is 6.5, or I can do 21.5 minus 15. No matter how you do it, you're going to get that the amplitude is 6.5. Of course, you could have also gotten that by doing 28 minus 15 divided by 2, because that's just the distance between them, and then halved, because it's only half the distance. So 13 divided by 2, which is again 6.5. So now I've got two pieces of my equation already, and I haven't really even done any work. So let's go on and look at the period now. Okay, so the period starts in January, and if we call this month 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? How long does it take me to get back to January again? Well, January would be the next month, which would then technically be number 13. But how long does it take me to go from 1 to 13? Well, the difference is 12. Okay, so I want the period to be 12 months. And so I'm going to use this little formula right here. 12 equals 2 pi over b. And I'm going to use that to help me find out what b needs to be in order for it to work out. So I'm going to multiply both sides by b. So So I got 12b, because I don't like variables on the bottom. Variables on the bottom of fractions are worse than fractions. Everybody hates, everybody loves fractions, but since everybody loves fractions, we get rid of them as fast as we can, and a variable in the bottom is even worse. So get rid of the variable on the bottom and get rid of the fraction and the variable on the bottom at the same time. So now we divide both sides by 12, and we got b equals, reduce the fraction, pi over 6. And so therefore b needs to be pi over 6. Now at this point I've gotten almost everything that I need, because I can go y equals the amplitude, which was 6.5, sine of pi over 6 times x plus c plus d, which was 21.5. Now, again, I think in the book, I mentioned this in my last video, the book may have minus. It doesn't really matter. That's just the horizontal shift. You can deal with it however you want. Most of the time, things applied to x are written as the opposite, so it's probably written in the book as a minus. And so you can treat it that way if you want. In the end, the formula is going to be the same. Now, recognize that for a sine curve, right? The sine curve usually starts here at 0, 0. It starts at the principal axis going up, right? So I need to find the part on this graph where I'm crossing the principal axis and heading upwards, okay? So when I look at my data, the principal axis is 21.5. So I want to be at 21.5 and heading up for this to actually be in the shape of a sine curve. So I look for it. Well, right here, there could be a 21.5. However, right there, the graph's going downwards. Now, you could easily take care of that just by putting a negative a, right? A negative a, the negative amplitude actually flips it. And so your graph would go like this instead of going up first. But, you know, I'm just going to simplify by not having to have negative a's. And so we'll go over, let's see, where's the next place where I get 20? Oh, there it is, 21.5 right there. So that shows that I am at the principal axis going up when x equals 10. Now that means that my graph has really just been shifted to the right 10 spaces. And so what I'm going to do is I'm going to go in, and for this, I'm going to make it shift right. And the way to do that is y equals 6.5 sine pi over 6 x minus 10. Because by subtracting 10, that's going to move it to the right, plus 21.5. And so I now have an equation that allows me to model the temperature at any time of year, any month. Okay, now just a couple of side notes, because I got a couple of minutes. I don't mind taking up about 10 minutes here. A couple of side notes. Sometimes, and the book demonstrates this, sometimes you can get C just by plugging a point in, right? You can take any of these points. You can take January, month 1, with a temperature of 28, and you can put 1 in for X, and you can put 28 in for Y, and it will give you an approximation of what value you need for C here, because then C is your only variable. That, of course, requires you then figuring out and doing all that trig and math to be able to get C by itself. A little bit difficult because it's inside the sine function, but with the knowledge that we have, it is doable. The other thing is, instead of subtracting 10, you could have just as easily moved 1, 2, 3 to the left. Instead of making the graph shift 10 to the right, we could have just shifted, I could have gone plus 3, which would take it from January and move it to the left 3 spaces. And so, you know, because it's periodic, you always have lots and lots of options. Lastly, like I said, you could have made the amplitude negative, which would have automatically flipped it over, in which case you could have maybe just shifted it to the right, 4.5 spaces. I mean, it's pretty close to 4 there. And so again, you could have done that as well. So you've got lots of different options and lots of different ways to set it up. Each one will give you a slightly different model. And so in some cases, you know, if you're doing this on an IB exam, you probably just want to go with whatever's the quickest and easiest to get. If you're doing this, you know, to try to model some type of real situation, you'd probably do all 3 or 4 models and see which one actually fits your data the best, because each one is going to give you something slightly different based off of the data that you put in. All right, well, that should be enough to introduce you to the idea of writing a model from data. We didn't draw it. We did kind of sketch it a little bit and play around with it, but we mostly just use the ideas and understandings of transformations and the terminology that we learned last class with the amplitude, horizontal shift, principal axis, and period to help us create the equation. Okay, well, I'll see you in class and we can practice. Good luck.